I found out that there are like tens of different research papers analyzing capital efficiency of different AMMs, comparing them with each other, and yeah, they actually define this thing differently. Some of them define it as ability to attract volumes per capital, some define as ability to earn fees per capital, some do normalization like yield or other things. But at the end, reading all those papers, I realized that I do not understand what is capital efficiency. And yeah, I will help you to forget about this also. So yeah, and we came from other side. We decided to check what we could spot and highlight as an efficiency. So yeah, we just decided to start from liquidity pools, AMMs, and we tried to analyze how much of their liquidity is being really utilized during the swaps. So we just measured minimum amounts, average amounts, taking into account deposits, withdrawals, and we found out that significant share of liquidity in the hugest AMM pools is not leaving the balance, so it's sitting idle. But for the most of the time, so maybe a few times a year, it is being participated, but those numbers are for 90% of the days in this year. So yeah, I think this is an efficiency. But what this liquidity is doing there, why it's parked in those pools? So yeah, the thing is that it is being partially used, but not being utilized. It's defining the price curve. So prices are based on this liquidity. That's true. But it's not participating in the swaps. This means that it is not actually producing or generating you trading fees. It's not. Okay, let's move on to what we could see as more inefficiencies here. That's how classic AMM pools works. Liquidity provider provide liquidity into a set of pools covering different pairs, ranges, different parameters. And yeah, if you would try to provide your liquidity to tens or hundreds of different assets, it's easy to notice that you have to fragment your most liquid assets, like USDC, wrapped Ether, wrapped Bitcoin. They're the most liquid in DeFi, and you have to fragment them to provide liquidity to long tail of assets. That's very inefficient because it's less likely this liquidity will be ever utilized properly. It will be underutilized in every pair. So that's also inefficiency, high fragmentation for liquidity provider. One more inefficiency here is that this liquidity is being locked in the pools. But what I mean on the word locked, you see, it have red locks. Red means bad. So actually being locked means that this capital is being restricted in its functionality. It can be only used for transferring during swaps. So takers can transfer them in and out, but any other DeFi functionality is disabled. Pools do not let you do anything with your capital. I would say it's DeFi disabled. That's one more inefficiency. So I highlighted three inefficiencies now: idle liquidity, fragmented liquidity, and locked liquidity. And we tried to solve it. With our new architecture, 1-inch Aqua, which is being shared liquidity layer protocol, we provide new approach. All liquidity is being parked in liquidity provider wallet. You see it have lock which is opened, which is green. Green means good. So yeah, all those AMMs, they can get shared access to the same liquidity to use it on demand when taker is willing to swap. And if each of those AMMs will be underutilizing the same liquidity and the same manner what you saw in the previous slide, combining multiple strategies, you could achieve much higher capital utilization. And moreover, this capital is unlocked on your wallet. This means it is DeFi enabled. I have more slides about this. So how exactly Aqua is working? I have very nice visualization here, which our art director drawn for me. So yeah, you could see that Maker have some assets on their wallet. And Maker could also define virtual balances per strategy. These virtual balances will be stored inside of Aqua. And yeah, whenever taker is coming to AMM to make a swap, AMM can get access to those virtual balances dedicated to specific strategy, can compute swap amounts based on these virtual balances, and then AMM can use pull and push interface to get access to those funds right from Maker wallet. Pulling assets from Maker wallet makes those virtual balances decrease. Pushing balance makes it increase. So initially, AMM could get access to like initial balances, but whenever it's changing balances, it can get access to everything what was brought there. So for example, it could pull all USDC here and push a lot of wrapped Ether. At the next phase, it could pull wrapped Ether and push a lot of USDC. So this AMM is working within balances, which is being accounted by Aqua. That's actually a thing how Maker can dedicate different virtual balances to multiple strategies, and Aqua would be like a security layer. For AMM, it's settlement layer and balance accounting layer. Second feature, like two features, like first is your liquidity could be shared among positions, and second feature is that it's unlocked. By unlocking your liquidity, you're making it DeFi enabled. This means that you could vote in DAO with your tokens. Oh, nice. You could participate in V-tokenomics. You could play around with other DeFi stuff your tokens are providing to you, finally. And moreover, you could play around with different DeFi protocols, like money markets. I have a slide about this. You could like leverage your liquidity, or you could borrow from money market on demand if you're willing to build such position. So how you could leverage yourself with money market? You could turn your 1,000 bucks of liquidity into 3,000 bucks of collateral and 2,000 bucks of debt. So you will have tokenized collaterals. You can't withdraw them. If you would try to withdraw all collateral, money market will check if you deserve liquidation, and they would just revert your transaction. So yeah, you should keep collateral in the same wallet where debt is. But here, you can put your tokenized collaterals, for example, in 3 different pairs of liquidity. And you would get like 6K of virtual liquidity. You came with 1K, got 3K by unlocked assets by using money market. You got like 3x amplification. And you also got 2 more x amplification due to shared liquidity feature. Those capital efficiencies are being compounded with each other. You could dramatically increase amount of liquidity of yours. You could have, in money market, you could have 5x leverage, and 5 tokens can be provided in like 10 different positions. So you could get like 50K virtual liquidity. That sounds insane, but yeah. The only thing how we should support this, Aqua itself supports it natively, without any additional piece of code, no line of code. But AMM itself, to fully support this use case, they should support flag for taker, which would make it first push liquidity on Maker wallet and then pull. Because you can't withdraw 1K liquidity from this. It will be reverted. Money market would not let you withdraw 1K liquidity. You will be not really over-collateralized as it would expect. But yeah, if AMM would support push and then pull, then yeah, you could trade here any amount. So what is capital efficiency now? I think we're redefining this meme, actually. I think it's no more a protocol metric. It's metric of liquidity provider effort and risk appetite. It depends how much liquidity provider is dedicated to supporting their balances above zero. If you want to spend like once a month or once a week, you could have some leverage. But if you are like really dedicated to this and do this like every hour, yeah, you could be probably 10 times more efficient. So yeah, capital efficiency is not a protocol metric anymore, at least for AMMs. So yeah, there was a conception of toxic flow, and I would like to redefine it. I would say that no flow is toxic anymore. It was called toxic because people decided that they can't earn on toxic flow. Toxic flow is like arbitrage volumes. Imagine no one is sending you volumes. In worst case, you would get arbitrage volumes for sure. And it was called toxic flow. But for me, if you have AMM and price went somewhere and you was arbitraged, and then price went back and you was arbitraged again, only arbitrage volume, at the end you have no impermanent loss, but you collected fees. Nice. You earned, but on toxic flow. How is that possible? Yeah, that's possible. But yeah, toxic flow usually means that your earnings are less than the risk of impermanent loss. So yeah, I think with this shared liquidity and unlocked utility leverage, you could earn even on toxic flow, even on arbitrage volumes. But I would like to redefine. It would be much better to talk about volumes on chain as a fair and unfair volumes, where fair volumes means that these volumes are deserved by your protocol by the prices it's offering. And whenever someone is trying to use every liquidity provider, every liquidity source, like DEX aggregators, solvers networks, they're optimizing exchange rate for taker. They are incentivized to consider every opportunity on chain, and they usually distribute their volumes fairly. That's what's a fair flow. But unfair volumes is something like using unfair competitive advantage. When you're sending all your volumes from your wallet or from your website to your own protocol or some protocol without considering other opportunities, this is definitely unfair volumes. I would say if you would check fair and unfair volumes for a long period of time, we're going to build analytics for this, but not yet. It is being more and more fairly distributed. I see more and more confirmations to this fact from different analytics, but yeah, we're going to summarize this at the end. So yeah. And here we ended with Aqua. Here we come to next section of my presentation. Aqua is defining a shared liquidity layer protocol. This is a layer for others to build on top. This is a layer for AMMs to finally compete with their formulas, not with TVLs. No more locked liquidity. So we tried to build our own AMM. We spent some time building different models, and in the end, we somehow came up to something really cool. I'm really happy to present you this new architecture. It's called Swap VM for a reason. VM means virtual machine. But yeah, it's not competition to EVM or Solana VM or any other VM. It's name of the architecture. This means that this program operates sub-programs which we could call instructions, and they're modular and composable. These slides visualize what it actually is. It's like a swap Lego. You could define your swap strategy for AMM, but not only AMM. It could be for anything what could be considered as a swap, like Dutch auctions, TVAPs, DCAs, whatever. But here is an example for AMMs. We're talking about AMMs. You could decide which invariant, which swap formula you're willing to have. I'm starting from bottom, yeah? Then you could define the flat fee you're willing to charge. or it could be progressive fee, or any other instruction fee which you could write on your own. Or this could be a concentration. You could be willing to concentrate your liquidity within some range, or maybe limit it from one side, only from another side. It's also possible. And yeah, the other thing here, decay spread, is something like when swap is happening, swap in back direction does not start immediately from improved price. It starts like a Dutch auction trying to sell it to arbitrage traders. And since it's Dutch auction, price is more favorable for liquidity provider. And yeah, those instructions are composable to each other. They can be enabled and disabled, and yeah, different options could be provided. But why we call it instructions? Why it's swap VM? It could be like a one piece of code with a lot of conditions. No, it isn't. Every instruction is a separate function, and those functions are being executed one by one, and they are only possible because of the data model which we invented. This data model is swap registers. It's 4 registers. It's balance in and out, amount in and out. This visualization shows that balances are actually balances of token in and token out. In means this token is being sent to maker. Out means maker is spending this asset. And balances are obvious. This is like virtual balances from Aqua, for example, yeah? And one of the amounts is defined by taker. The taker could either define amount they're willing to spend or amount they're willing to get. And the whole idea of instructions is to finally compute the missing amount. When both amounts will be computed, they will be non-zero. This means that this is something what should happen. So those instructions, they only taking care about computing the missing amount. I have few examples here of instructions. How does they work on top of this data model? The very first and very obvious one is constant product. It makes sure that the balances multiplication before swap and balances multiplication after swap matches. So yeah, it only checks which of the amounts is missing and computes it based on simple formula. It's pretty simple to derive it. It's like a few lines of code, for sure. And this formula does not have any fees in it because we have a separate instruction for flat fees. But this instruction is a little bit more difficult than we expected originally. You could check it in the code. I don't have it in slides because I don't want to like dig deep into flat fees. Sounds simple, but implementation was a little bit tricky because we tried to make it symmetric for exact in and exact out. We don't want one of the exact swaps to be more favorable than another one. This would make another option to swap non-sustainable economically. So I only have simple instructions here as examples, like concentrated liquidity, yeah? Want to see it? Okay, that's it. To have concentrated liquidity, we only have to increase balances by some deltas computed off-chain. There are cool formulas to compute those deltas. Yes, it's easy. You can do it with the school math. But the thing is that for smart contract, those deltas are kind of constants. And yeah, your real balances would walk on the bottom line. It will be naturally preventing you from getting out of the range by draining the balance, virtual balance. Meanwhile, virtual balances which were increased and which were used for constant product formula, they would walk on this invariant. So idea was that if we would just increase balances, then constant product formula would try to spend too much balances during trading. And the idea was to find constants which would increase it that way that when it will spend all the balance, you will reach the desired price range. It's a bit tricky that if you would try to collect fees, this range will increase actually. But yeah, it's also manageable. We have two instructions for this. One instruction is growing in price range when collect fees. Another instruction is growing in liquidity, maintaining price range. You have a little bit different name like XYC, concentrate, grow price range, and grow grow liquidity. So yeah, the only thing is different for maintaining range is that after collecting fees, after computing swap amounts, we readjust those deltas by invariant increase. Invariant is multiplication of balances. So we check new multiplication of balances, we check old balances, and then we easily get how to readjust those deltas, multiply by one and divide by another. So yeah, this was easy. And yeah, one more instruction here is for Dutch auction. So yeah, it actually starts, it's like a chart for balances. And it starts where red line starts, and some swap happens, and where real balances are where blue line starts. And what happened next? When you try to swap into opposite direction, it does not start where blue line starts. It starts on the old place where red line starts. And then red is like a virtual balances, which are trying to go to real balances. And at some point, arbitrage happens. I'll show you. Here it is arbitrage swap. So it's being computed via virtual balances where red line is, but being also applied to real balances with the same swap. And then again, virtual balances are trying to reach real balances, and at some point arbitrage happens. Yeah, you see it? So yeah, this continues until virtual balances matches with real balances. Yeah. And this would be more efficient for liquidity provider. Liquidity provider is not giving away this arbitrage opportunity, but selling it with Dutch auctions, where arbitrage traders compete with each other. And yeah, we implemented this thing originally like 5 years ago. It was a project called MuniSwap, and we saw that liquidity providers' earning increased 2 times. Meanwhile, arbitrage traders' profit decreased like 10 times, because at that time they were earning pretty comparable amount of money, arbitrage traders and liquidity providers. So now you could use this instruction as part of the logic of your swap program, swap strategy. And now this instruction is also composable with concentrated liquidity. So yeah. That's final information for builders. If you are willing to build AMM, we're giving you new way to have this. For sure, you could build your own AMM on top of Aqua. It's permissionless. From Aqua point of view, AMM is just an address which can use their APIs, balances, pull and push. But you're also enabled to try to build AMMs by building instructions for virtual machine. This means that whenever you're willing to develop AMM, you are actually coming with a cool formula. You came with your secret sauce, but previously you were required to make a lot of things, write code for deposits, withdrawals, balances, shares accounting, swap settlement. Yeah, you had how it's called code level composability. You was able to use any code you can find online according to its licenses, yeah? But yeah, what Swap VM offers you, if you would be able to implement your secret sauce logic as instruction on this data model, you would effectively avoid writing a lot of code. And your instruction will be composable with some other instructions. Not with every instruction, but with some of them. So yeah, it's definitely possible to compose programs which makes no sense with those instructions. But yeah, you're developers and you can write programs out of those instructions which make sense. So yeah, understanding those instructions, how they work, and maybe paying attention to their names in the code would give you a clue which of them are composable with each other. Some instructions are single directional, some of them are bidirectional, like for AMM. So yeah, I see a huge opportunity to build in this specific space now, because there is like a possibility to compete on an absolutely new level. You don't need to compete for TVL anymore. No more locked assets. You can compete with your formulas for specific market. You could try something interesting. You could try to find something interesting where your formula would work perfect for some specific market, specific pair, specific range, specific nature of order flow. The more it would be beneficial for liquidity providers, the more efficient it will be making the market for takers. So I hope to see this AMM market pushing like really forward for efficiency and be much more efficient than traditional finance in a few years. Thank you. We have time for questions.
Hello. So I think I came from the session on Monday, but I still have a few questions. So when you're implementing like the opcode, you say you do not need to have deposit and withdrawals, but how are you going to essentially match the takers and makers given a swap VM instruct?
Yeah, I think I got the question. Yeah, the question is taking care about takers here. Yeah, the thing is that takers are getting smarter and smarter. Actually, takers nowadays are DEX aggregators, solvers networks, which are considering all the possible opportunities. Aqua itself is doing nothing for this. It's a settlement and accounting layer for AMMs. It's a business of a taker to take care of which liquidity sources, positions, strategies to use, because takers are optimizing their trades for the best price. This means that they would be considering every opportunity. We have 1-inch aggregator. We know how it works, and we are already dedicating our volumes to these positions. Whenever these positions will be appearing, we will be using them to improve exchange rate of every trade. So yeah, but even like if you would not believe me, anyway, you would get arbitrage volumes. And yeah, for sure, there is like a direct incentive for every solver, for every DEX aggregator to integrate every position, because the more positions they have, the better prices they could offer for takers. They are very incentivized. And we have to do nothing with this on Aqua layer. Thank you.
One more question. So the maker USDC web Bitcoin are all accounted as like ERC 4626 vaults, or like, so for example, if it's on Aave or 4626, like how would you program like a series of opcodes to withdraw liquidity and trigger like the trade on Aqua?
Yeah, you asked if those assets will be in vaults which are 4626, yeah?
Or even like on Aave, like how would the opcodes look like?
That's interesting. I do not remember if this ERC is compatible with ERC20, if its shares are tokenized or not, but if it is tokenized, yeah, I think this would work. Anything what looks as ERC20 would work here. NFTs also probably would work, but I'm not sure it makes any sense to have AMM with NFT here, yeah. But yeah, you can make limit order AMM if you are willing to.
Hello, I just wanted to ask, would it be possible to fund AMMs across different chains with Aqua using the same assets?
No, nothing related to cross-chain here. But yeah, regarding the chains, that's actually very good news, that every chain would be getting a much deeper liquidity with Aqua. And Ethereum mainnet liquidity will be infinite deep. Thank you.
Hello. I read the white paper and it said that once you put the position that you open the virtual balance, it's not being tracked afterwards by Aqua. Is there any way to make it trackable? Because that will make you lose some trades if it's not being tracked or like...
Yeah, that's actually, I think, like two questions. Yeah, what would happen if you have not enough balance for the swap? Yeah, takers will not be able to provide you volumes. You will be like in a illiquid state. And for everyone who is in a liquid state, I would recommend close illiquid positions first and then refill your balances. But even if you would refill balances without closing those positions, you would experience immediate impermanent loss. This is not something good because it's like arbitrage traders earning on you, but this is impermanent loss. So it's manageable, we can and you can work with it. And from other side, from the taker point of view, this problem is very similar to limit order protocols, which are currently running on chain. The thing is that you could have limit order with balances, but you can have no balances on the wallet. It's still taker business to recognize this and not to drive volumes to not get reverts. Because when Aqua will try to pull, it will call ERC20 transfer from, and it will just revert due to not enough balance. And it's business of taker to not fall into this trap. So yeah, we are running aggregator, and we are taking this into account. And other solvers and DEX aggregators will do the same.
But the taker will think that there's balance because of the virtual balance, but when he actually executes the transaction, it will fail? Or am I missing something?
Yeah, but takers are getting smarter and smarter. All those solver networks, they understand how those things working. So they're not just quoting and swapping. They have deeper understanding of this thing, as we are and as others do. They read documentation, they understand how it works. Maybe in the first integration, they would see something went wrong, they would analyze and do this. I mean, that's inevitable for them to understand and take this thing into account. But initially, when they will approach this, they may face some problems for sure. But yeah, that's like debugging and understanding of the protocol. Anyway, takers are getting smarter for the past 5 years.
Thank you.
Welcome. Okay, thank you for the questions, guys. I will be still here for some time, not here, but near the booth. So yeah, if you have additional questions, you can meet me or my teammates and ask them. Yeah, you can ask questions online. We also have this workshop recorded earlier this week. It's available on YouTube, 1inch on YouTube. Yeah. Thank you.